Started, Roger.
Thank you. All right, welcome folks again to our Sunday session. And so I know there are a lot of new folks, so I thought I will start with what we have covered so far with Sunday session. Things started in February, a lot of new folks were coming from colleges and they started this thing, and we were having this thing called LeetCode daily sessions. And then we started to experiment on Sundays. In the beginning, we did a couple of contest problems, and then we started to focus on a particular topic. So since a lot of new folks are here, I will just let them know that I have done sessions on intervals, most likely in March sometime. Go and check. Unfortunately, this session was just 1 hour. I wanted to cover more things, but yeah, I got a call or something happened, I remember. But yeah, take a look if you have time. Then there was a monotonic stack session, which was done, followed by that. We had system design basics. It was actually especially for the folks who are less experienced. So it's a good session for them actually. And we have another weekly session now every Saturday. So I'm pretty sure you guys are following that, but yeah, just want to let you know, you can take a look if you want.
That's system design one, right?
Pardon?
That's system design, right?
Yeah. But I did one session, on one Sunday,
Okay.
earlier. It's a 2-part series. Then we did LeetCode buy sell stock problems recently. There are a lot of 6 problems, and we covered it using a common approach. And then we learned about some space optimization techniques in the next session. Also, Gaurav did DP introductory sessions where he covered a couple of commonly asked problems and how to approach them, like point changing and knapsack, those kind of problems. So you can find that in our repo, YouTube channel. Bhavesh did excellent, on union find. I think must be 1.5 months back, 2 sessions on union find. So go check that out. And DP did recursion and backtracking recently. So it's very good. Actually, it is going to help me because today we are going to use a lot of recursion. So,
Okay.
So it sounds good actually. The sequence is pretty good. So any question on that? Feel free to ask now, or we can move ahead.
Yeah, I think we should start.
Okay, great. So, okay, what are we going to solve and what are the expectations? My question to you guys are, how many of you are familiar with the digit DP or heard for the first time? Didn't even hear about it. I can't see actually. So. First time. Okay, good. I like my sessions are always for newcomers. That's why all my sessions should be should have suffix for basics with everything. Okay, so a lot of first timers. That's good. Okay. So, okay. I will show you what we are going to cover.
One question, does it go to the hard category, or is it applies to all the easy and medium and hard DP?
So what I have seen, all the digit DP problem is considered hard.
Okay, then fine, yeah, because I never focused on the hard DP, so yeah. I never tried to. Okay, thanks.
Right. So what I am going to think about it, think about your current level, how good you are going to feel about the questions. I have already shared the questions, but people who are going to watch the recorded sessions, I'm pretty sure will have those questions mentioned on the YouTube channel also. So go take a look before this session. How do you feel about it? And then see how do you feel about the same problem after the session? I hope you will see some use of your time, but that is my expectation from myself. We'll see.
Okay, nice, that's good.
Yeah. So let's go to like which problems we are going to solve. Just giving you tool of what we are going to cover. So like on LeetCode, we have these 6 problems. We'll not go to the problem now, but just showing you like number of digits 1, as you can see, it's categorized hard. Then number 600, which is hard. Number at most in given set, hard. This is considered medium. But when I will solve this problem using the exact same code in this problem, then I don't know why that was medium and why it is hard. So we will see that. And this is a actually a very hard question. So it depends on some understanding of KMP, but since this session is more focused on digit DP, so we will not go into KMP part of it, but I will still show you the overall solution. However, see, since all these problems were hard, I wanted to solve these problems. And then I thought, how should I go about going through all these problems without giving you basic problems to understand? And that is why for the first time, actually I went uh, out of LeetCode and started to find problems which is more basic actually. So we'll go through this problem, digit sum, on Spoj, and from add coder, we'll go couple more problems as I am showing you. These are all the problems. Let's not go into all, but just showing it in case if you have done, you will recognize these. Uh, this problem, somebody said, why not any question from Codeforce? And as you can see, this problem is actually big enough. So we'll see if I have time, we'll cover eventually, or otherwise uh, I will just provide my solutions and you guys can go and read through it and ask me questions on Discord. We'll see how we are going to cover it. Definitely we are not going to cover everything in one session, it's for sure. So my idea is we'll cover some of these problems today. Like these are basic problems, and it would be great if in next session, before we start the session, you guys go and try to solve some of the LeetCode problems yourself, and then when I will go and cover that, it will make more sense. So that is the big picture. That is how I'm going to cover the session. Sound right? Anything on the chat which I should answer? Can somebody look into that parallelly or ask me question?
Is
Yes, sure.
it possible to attach the document list of questions you send it with along with the YouTube video? Because in the Discord, it's hard to follow the thread, and you lose the what was shared for which session. So if we can just attach this with the YouTube, which we upload on the SDC list of problems you had shared earlier.
Right. So normally on YouTube channel, if you go and watch our sessions, at least I go and check my sessions. I do see always there is all the problems listed below it.
Okay, description. Okay,
Yeah.
okay.
Yeah,
Thank you.
one suggestion that if you can make a Google Doc for it and list all the topic wise, so it will be more convenient. With the
Like at
YouTube.
least one place it should be wherever it is convenient for you guys.
Yeah, so I think Google Doc will be more convenient for all the sessions, Sunday sessions, I mean.
Okay.
But I think we have our own GitHub, right? So we can actually post everything there.
Yeah. That can be bugged out, I think.
Like when we use the YouTube, then we have to go different route and find out what it is covered in this session before starting the session and going through everything. So sometimes it's easier to just see which session, this session is going to cover how much and what problem and all those things. So it's just easier to navigate through the YouTube videos because I'm watching a lot. So just a suggestion, whatever works for you guys.
Yeah, whatever works, you can discuss on Discord for sure. So let's start.
Yes.
And I will ask many questions, and hopefully you guys will answer. That is how it is going to go. So my first question is, like, suppose I give you, let me see if I can type here because I want to, okay. Suppose I give you between 1 to 100, like suppose here, let's write 1. Sorry, I'm just getting used to this tablet. 1 to 100. How many numbers are divisible by 3? If somebody is replying on the chat, I'm really sorry I can't see your solution, but yes, I really appreciate you, participating. So
33.
yeah, my question is, okay, now I have to calculate the sum uh, for all the numbers between 1 to 100. So basically, sum for 3 plus, let's say, 6 plus up to 99, right? I mean, these are the only numbers which are divisible by 3. So what would be that? How would you proceed and solve this problem?
So we can take, I think, 3 as a common, and then we can find sum of first 33 natural numbers by formula n into n plus 1 by 2, and we can multiply it by 3.
That's a
This is
pretty
an
good answer.
We can make an array and push into it everything, and then add that array. 3, 6, 9. We will push into an empty array, and then we may add. Does
Okay,
that sound good?
that sounds good, but you are using space, but someone else suggested a solution which will not use a space even.
Yeah, that will be constant
Okay.
time.
Yeah, so I mean, both are right for my constant. Uh, I would have done similar thing. I would have looked at this in another way, like 3, 6, it's an arithmetic progression, and there is a common difference of 3. So I know there are 33 numbers. So something like this, 33 by 2, and first plus last number, like something like this will also work, most likely, right? So basically, this was a problem which is based on digits, and you guys probably, like a lot of don't know digit DP, but you can solve this problem, right? Using basic number theory, or let's call algebra knowledge. So, and probably this will be would be the better solution than what we are going to learn in this session. So don't always think that uh, digit DP we should use always. I'm just providing a couple of questions where you can just go without doing it. Okay.
Yeah, yeah.
So, okay, let's erase this, or maybe can I type below? Yeah, let's continue typing. Now my next question is, uh, how many 5-digit number? I want to make 5-digit numbers. My set of number is not everything. My set of number is 1, 2, 3, for example. And I have another constant here that the numbers should be like non-decreasing, like each subsequent digit is non-decreasing. So I will show you the example, which kind of number I want. So something like 1, 1, 2 is good. 2, 2, 2 is good. 2, 3, 3 is good, but I don't want to have 2, 1, 3, because here I don't want to have anything, in subsequent digit less than it. So this is wrong.
One question. You said 5-digit numbers, so
Oh, sorry, yeah. So let's
We
make,
can make it 3-digit.
to make it 3-digit,
yeah, or make it 3-digit actually. That would be better. Make 3-digit number. Okay. So how would you go about solving this problem? I mean, if somebody knows, good, we'll wait.
one thing would be to recurse
Mhm.
and keep the track of previous number added. And if current, you will consider current number only if it is greater than or equal to the previous one.
Yeah. I
So
mean,
that way, I think you can count. We have to count all of them, right? Or we have to take sum of all of them.
so you can anyhow you make three digit number. So
Yeah. So and whenever we reach end, we'll keep adding to it one set, and
oh
then
yeah,
get.
yeah. Right. So you have to give number of, not like you count of the numbers. So
Yeah.
okay. So that's a good approach. Like you're doing recursion, that would be okay. And as the number of digits will increase, it will get interesting. But that's a good idea. Anybody can think in terms of combinatorics. Uh, Does it
Yes,
sound? Yeah.
sorry, I was thinking that we can go with like something like permutation combination and a naive approach where we set the first digit. Now we know that the second digit can only be among these. Then we know
Right.
the third digit can only be among these. So like that, and we know how much numbers we can arrange out of them. So that way we can get the count just by permutation combination.
Yeah, it's a good idea. So if you're thinking at least in terms of combinatorics, and that is the point I was planning to make, that you can solve using that too. And maybe if you can do that, maybe sometimes it could be a better solution. So, so think it in this way, uh, that you have couple of objects. So actually, let me make it, because it's a useful thing. Not just three, I'm just showing you the example, right? You know that I can choose one or I can drop one, right?
Yeah.
I can choose two or I can drop two also, even three, right?
Yeah.
So, so suppose these were the digits. If I place any bar, like, like this, let's call it bar. I divide it in two sections already, right? One section has nothing, one section has like say 5 of these, right?
Okay.
If I put another one, then how many sections are there now? 1, 2, 3, right?
Yeah.
Every time I put a bar, I am increasing one section, right? So if I have to, like suppose if I have n digits and I want to make k digits, like, or choose k digits out of it, all I need to do is somehow choose k minus 1 such bars, right? Does that make sense? Because one bar will lead to, see, like, first bar leads to 2 sections, then second bar leads to total 3. So choosing k minus 1 will give me k minus 1. So now if you think like this, all you have is in this line is n plus k minus 1 objects, right? Some are star, some are bar. And what I am going to choose, I'm going to choose k minus 1 bar out of it. So any problem understanding this? This is not the main topic, but I just want to, like, since you are spending some time, why not just learn it?
So number of character will increase to 2n minus 1, right?
2 and
Why
minus.
did, why did we take
Because
n plus k minus 1?
See, so I am going to put k minus 1 bar here, right?
Yeah.
so why, how do we use that k minus 1 bar?
So
Like
now,
what is the like?
so okay, wait a minute.
Can we
So now
define
look at all
terminal?
this.
The
How
n what is
many
here?
star plus bars are there? There
7.
were there were n already stars, right?
Hmm.
And we put k minus 1 bars, right?
Yeah.
So if I will ask you how many total objects are there, is,
Okay, got it.
is it right?
Yeah, yeah, got it.
And I can put bar anywhere.
Mm-hmm.
So Now, if you try to run this, just because we used 3 digits, so what I am saying, okay, 3 digits, so n equal to 3, k equal to 3. So what we are saying, 9 n plus k minus 1 means 5, right? C2. 5C2 is what? 4 into
10.
5 by 2, 10?
Yeah.
10. Okay, so since this is a easy example, let me try to even write the numbers in the order. So 111 will be the first one. I can write 112. I can write 113 also will work. Then 122. I can write 123, right? 123, 133. I think 1 can only give me that much. Then starting with 2, I can have 222, 223, what? 233. And with 3, if I start, I have to only put 3 subsequently. So 6 plus 3, 9 plus 1, 10. So yeah, that is right. So
What is your 5? Where is 5 coming from?
so in this formula, n was 3 and k equal to 3. So n plus k minus 1 will become 5, right? You know, this was the formula we just derived.
Could you please go to the star and bar? What are those things signify?
Okay, sure. So good thing is, if you search about a star and bars on Google, then you will for sure find better explanation than me. But let me try to still explain it. So all these stars were my digits, right? Okay. And we are arranging it in a, every time I want to partition it, I can put a bar somewhere, right? That is how I am trying to represent it.
Okay, okay, got it.
Okay. So
So why is the
Still go
subscript
through it
k
again.
minus
What?
1?
We have 3 digits, so why we have 5 stars?
that was the example. So you can just put 3. My example was for n and k minus 1. And the
So we are
idea is,
selecting.
yeah, idea is anything is arranged. If I put 1 bar anywhere, let me put it here. Now there are two groups for it, right? I can put 1 here, and there are 3 because this means nothing. And then this and this. So if you are actually, this is not a combinatoric session, but the idea is look about stars and bars on Google, and you will find more examples. And so
No, so, okay. I mean, what are we trying to say? The number of, there are n minus, k minus 1 ways to place, given n stars, what is the relation between stars and bars?
so now n plus k minus 1 means combination of stars and bars when I arrange it. Okay. And I'm choosing k minus 1 bars out of it, because I know if I choose k minus 1 bars out of it, then I will have let's call it bins of different digits.
Okay.
So you mean like from every partition we'll be selecting 1 digit, right?
Every partition I'm selecting 1 digit.
Like we have k partitions and we want k digits, right?
Yeah, in this case you have only 3, right? But if you had 1 to 10, you can select 1 to 9, for example, and you are choosing only 3, then, or maybe you are choosing only 5, then your k will change, n will change, and you can see all the permutation combinations, how it plays out. But since we chose really simple thing, this is how it will go. The core thing is to understand when you place a bar, you are separating it in 2 groups. with the first bar. With the second bar, you are making it in 3 groups. And all we want is K groups, right?
Yeah.
So for that, we have to just put K minus 1 bar somewhere. And yeah, feel free to go through this. This is a well-known thing. If you do Google search stars and bars combinatorics, I'm pretty sure Wikipedia or something will have some better examples.
Yeah. Okay. I'll go
I
through
think
that.
Roger, one question is there. Why it's not NCK?
Why it's not NCK?
Yeah.
So NCK means out of N you are choosing K, right?
Yeah.
So what does that mean? Like 3C3, right? That will be 1. So, and you cannot choose okay, let's see. NCK means 3C3 means there is only one way, right?
It's the same thing, I think. NCK is equal to this only, N plus K minus 1, CK minus 1.
NCK is
Similar to this only. NCR is equal to what? NCR you can do
NCN minus R.
NCR minus R, right? So if you evaluate it, it will boil down to same only, NCK, I think.
no, I don't think. I think isn't
Because,
3C3 1?
yeah, 3C3 is 1. That's correct.
Yeah, NCN is 1.
Yeah. So you are saying like out of n objects you are placing K. That actually doesn't appeal me. Like how? Why should we do that? You choose any.
You are adding extra K bars to the star, right? In NCK, what you are doing? You are just picking K stars out of N stars. Here you are adding to the N stars K extra bars.
Yeah, I'm using K minus 1 bars because that will give me like now my problem simplifies because now I can place, I know that there is total of these many items, right?
Yeah. So
And
when you add K minus 1, so total number of stars plus bars is N plus K minus 1, out of which you are choosing K minus 1 bars. In
yeah,
NCK, out of stars only you are choosing just K stars.
okay. So I don't think so. You are saying that is a solution. NCK is the solution for this.
No, this is perfect. NCK should not be the solution for this. This is correct
Okay,
because
yeah.
we
So
are adding extra K minus 1 bars to the stars.
got it. Yeah. So I'm saying the same thing.
Yeah.
So go ahead.
When we add bars, for n stars, when we add bars, we are only adding bars between the stars. We are not adding on the edges.
Yeah, between or on the side also, right? Because we can choose 0.
But if you add on the side, your K will be bigger than n.
Yeah.
If you have 5 stars, you can add 4 bars. So in the middle. But if you take the sides also, then you will have 6 bars, K plus 1.
Let me just, while we are here, stars and bars combinatorics, let's do it. And there are 2 rules I know, but I don't know who has the best explanation. So guys, go ahead and read about these. There are theorem 1 and theorem 2. So I am using this theorem in this particular case. You may be talking about the first one, but look at that also. First case is where you can't put things on the side, and explanation is similar. So go and read about this after this session. Okay, does that sound good?
Yes.
Yeah, sure.
Okay.
Sure.
First result is that. So okay, where we were. So we know a way actually to solve this problem. This problem also looks similar to like some digit problem, but I don't always have to go and solve using digit DP if I know some combinatorics. But using digit DP, we could have solved it, I guess. Now what I want.
So, Roger, 1 second.
Yeah.
We did 5C3 and 5C2.
Yeah.
And we got the 10, right?
Right.
So what does it mean? When you wrote down, Can we take one example and see where placing the bar gives us which number? So how do we derive one output like 122 or 123 from our numbers and putting the bars? How did we get 123 as one of the combination out of 10?
Are you asking like how? I mean, based on the rule, I wrote this example, right? This example you're talking about, right?
So how this formula is using that rule? That is what.
Yeah. So okay. So you have 3 bins, right? In this bin, you are only putting 111 means you have chosen this kind of combination. Okay, let me put it here. You have chosen this kind of, sorry, 2 bars, right? We only choose 2 bars, leave it. So this was your 3, 1, 0, 2, and 0, 3. Do you understand? For 112, what does that mean? Like here is how your thing was happening. So you choose 2, 2, 1. So this bar means 2, 1. We put 2 bar, this means 1, 2, and this means 0, 2. This is for 1, this is for 2, this is for 3. Does it make sense?
How this conforms to our rule that it should be in the increasing thing? It should be non-decreasing basically.
Because the numbers are in that order, right? 1, 2, 3, it's already,
okay.
The bins are automatically arranged like that. I know
It's
that.
sorted basically.
Yeah, 2 is bigger than 1 and 3 is bigger than both.
So we are sorting this first and then doing it.
Even this problem, yeah. If the problem was like 3 to 1, for example, right? Will that matter? If
I guess the thing is like we are choosing only the k bars and not the numbers which is present over there. So we are just messing up with the k bars alone.
Yeah, I think the bins are identical, so it won't matter. So even if you take 2, 3, 2, the bins are identical.
But it is not the increasing, right? The first rule is that all the numbers which we are selecting should be.
All the numbers will be in the increasing manner. So you will be placing the bars at the in different positions based on the n ways, as the formula says 5p2 is equal to 10, where you will be placing the bars, 2 bars in 10 ways, so that you will end up with these 10 numbers, possible numbers.
We are excluding those numbers which is not increasing, right? Here in the next column.
It's not like that. The numbers will be in the increasing manner, but the thing is that you will only have 10 ways to place the 2 bars.
Yeah.
And it doesn't matter, if for example the number is 232, then we are just interested in the count. So 232 will give rise to a number 223. So that would be taken care in the count thing.
So the rule is just we are not applying the rule in it.
We're just selecting k numbers out of those n numbers and filling those k bins. And as somebody said, those bins are identical.
Exactly. Doesn't matter where you put 3 or 2 or 1 or 5 or 6. You select it, and then using that you can form the number, right? You have to form the number. They have given you in any format, but there is a way to form that. So should we move ahead? Since that is not the main topic, I was just giving some food for thought. So
yeah, move it.
Think about it, look at it after the session more, and then hopefully that will make more sense. So, okay, let me erase here. So by the way, there are 2 rules. So there was another rule when there was no restriction, like where you can put the things on the side. I mean, the rule is when you have to choose at least one bin of one type, then there is a different formula, and that is a little bit easier. That is, by the way, n minus 1 c k minus 1. But go through that article I did show you.
Before you erase, one last quick question. So in the x-axis, the example 1, 2, 3 you put, how did you know that the first two XX are going to be 1?
How do I know first XX?
Like the number you put 1, 2, 3.
Yeah.
How did we derive that?
So I can put here the smallest number. Let's not call it 1. The first smallest number, second smallest number, if you want to generalize that.
Yeah.
Make sense?
Yeah, kind of. I mean, we were saying that we are not going to place bar at the end. And in that example, we placed it at the end.
No, we said we will we can place the bar in the end.
Okay.
Why do you think we said that? We can choose 0 item of one type. Didn't we choose 333? When we choose 333, that means that we are not going to choose 1 and 2. So maybe you misunderstood or I misspoke. So that could be the reason, I guess.
Yeah, need to study this actually properly. Okay.
Yeah, I mean, that's the idea of this session. Like, it's not just one thing. We'll do a lot of things.
Yeah.
So with that, let's do our next problem. Make it interactive. Find the maximum possible sum of the digits in base 10 of a positive integer not greater than n. Okay, so let me try to explain the problem here. You are just given n. So if we have 100, then the problem is what would be the maximum value of any digit between 1 to 100. So maybe 99 will be 18, right? Because 9 plus 9 is 18. Anything else will have value less than 18. So that should be your answer. And then 9995, this is your limit. So from 1 to 9995, what is the maximum sum of digit you can get? So as explained in this, 99989 is 35. So, okay, that's the problem. Let me try to put it here and think about it. So this example is better. 1 to 9995, sum of digit, right? Whatever you can form, the biggest sum of digit, that is the output. So the answer was given that if you choose 9989, it is 35 because you can just put plus in between, and then that is 35. Okay. If you choose just 9995, then that would be how much? 32 maybe? If you just choose 9 plus 9 plus 9 plus 5, that would be 32. So how would you go and solve this problem? Anybody has any idea? Think about it. I will take 1 minute break and then you guys can discuss and suggest any solution or any other ideas.
Yeah, I think each place has 9 possibilities, except each place has 10 possibilities except the leftmost place. So, and we can try at each position the digits and to check out the maximum sum which we can get.
I don't think each place has 10 possibilities. Here the number is 9995. So maybe because of that you're saying, but it depends. Because we have to look for the numbers just less to the given number.
Yeah, so while calculating the possibilities, we should make sure that it should lie in the given range.
Yeah, for example, in this case, I don't think we can try 6 at the units place.
Yeah, you can't.
Yeah, I'm back. Yeah. So, okay, do we have any ideas? Can you repeat if somebody has ideas? Okay, somebody asking for question also, like, okay, so question is, You have been given numbers from 1 to n. In this given example, we have numbers from 1 to 9995. That means 1, 2, 3, 4, 5, 6 up to 9,995. And we have to find like what would be the maximum sum of any digit. So in the problem, it was given that if I have this digit, then it will have some 35, which is the max. That's the problem. So
I was thinking of a greedy approach. I'm just thinking aloud, not sure that it's going to work or not, but we can maybe start from the unit digit and see what is the maximum digit we can put there, and then go to the tens digit and hundreds digit and uh, just try to maximize the sum in that way. So in the given example as well, had the number been 8,999, that is still less than the given number, and the sum of the digits would be 35. So not sure whether that's going to work for all the cases, but that is just one greedy approach which came to my mind.
so you are going to select 9 here, you are saying, or from this side should I go?
Yeah, from that side.
From 5, okay. So here you are going to put 9, then you will put 9, then you will put 9, and then here you will put 8 or
Yes.
9. Okay.
So I'll try putting 9 there, but that would increase, that would go beyond the given number.
Okay.
Hence, I would just decrease there.
Okay. All right, that's a good idea. Anyone else has any idea?
I have one idea.
We
We
can
can
start
scan
off from the units digit, where whether we can keep the number as such, or if we try to maximize that number, we can reduce the number to its left.
Okay, that's the same approach, I guess, which Bhumik was talking about, right? It's kind of similar, but he mentioned in a different way, similar to that, most likely. But we will see. I liked your approach. Who was this? Sorry, I can't see your name. Harish?
Yeah.
Okay. All right. Yeah.
How about approaching using the try approach and add all the digits, and the last sum would be the leaf node. And at the end of the day, once we have built a try structure and just compare the leaf nodes and get the maximum. And all we need is like traverse from root to that one.
Okay, so you're building a try.
Yeah.
Try of all the digits.
Yes.
And then you keep choosing. Okay. Maybe.
I think all the solution is using the recursion, right?
Yeah, I was thinking of like this recursion and backtracking idea.
Okay.
If I start.
I was
Nobody
thinking that
likes
we can
brute
scan
force.
it. Can we scan it from left to right, and first digit, which is not 9, we convert it to the previous one. Like say take for example 735 is a number, and then we want to find that what 3-digit numbers less than 735 will give us maximum sum of the digits. So it will be 699, I think, right? So basically you scan from left to right, and whatever is non-9 or which is less than 9 that you find from the left digit, you move it to the
right.
You move it to the previous digit, and rest of all digits will become 9. So that will give you a solution. And a special case would be that your only non-9 digit is the last digit, in which case you need to make the second last digit as 8 and remain rest of them as 9.
Okay, actually, it's a good idea. I think other guy was also talking about similar idea, and most likely Bhumik's idea would have led to exact same number when he was trying to start placing 9 from the first digit and going back. I'm surprised nobody likes to think in brute force that, okay, start from 1, go to 2, go to 3, and do basic maths. But actually, I was looking for this solution. So great. So if people don't understand this idea, I will just reiterate that suppose the number was 999. or actually we have 4-digit number, so let's put 9999.
Let's take a number without 9 because that actually oversimplifies the problem.
We will go through that, okay? Because it will give you something. That's why I'm putting all the 9s, okay? So when you have 999, you know you can't get anything better than this, right? All right, so suppose this sum of this is called S, right? 36 basically. Now, suppose the number was 9995 as given in that example. As somebody just said, why not transform it to, I know that I can get the best I can get is 49. That would have been my dream. Like, that would have been my best solution. But if I just remove 1 from here, then I can still form the next best, right? If I just put from 9, I will put 8 here. I can create 999 here in the end. And that would be your sum minus 1, whatever was that sum. So this is a special case when everything is 9. If I have in that special case, well and good. If not, then I can go to most significant bit, delete the first digit, not delete, actually update the most significant bit by -1, and then I can get a better solution. So now, which number you want to take? Like somebody was asking, like, don't take 999. Let's take that now. Do you have any number in your mind?
Yeah, just take like 2732.
2732. Okay, we know that we don't have all the digits as 9. Okay, so what someone suggested that, okay, make this 1 and just put 999, because that will ensure that we are still we are smaller than this number, and I'm trying to maximize values for all other digits, and I am just leaving 1 extra, like, a delta here. Does that make sense?
Yes.
Yeah.
I think so, yeah.
All right. So actually that was a very good idea. And did we use anything like here, digit DP or anything? No, we didn't. I will show my solutions, which is exactly similar. So just if you are interested in the code, it's same thing. My option 2 was adding all the 999 basically. I go to the entire length. I just add all the values. That was my option 2. My option 1 was make first digit 1 smaller and rest of those as 9. And then I just choose whatever is the maximum among those. So that's the code for that. And now we have discussed 3 things. First one was
one question. How this was the application of digit DP, your solution? Was it the application of digit DP?
No.
No, okay, thanks.
So yeah, so now we will go there. So 1 hour and then we are not started yet. Sorry about that, but I hope you are still enjoying the journey. That first question was arithmetic progression or number theory, and we could solve the digit-based problem using that. Second one was combinatorics, still digit-related problems we could have solved using combinatorics. And this one you could solve using brute force or digit DP, but somebody thought about it, and now this will have one of the best time complexity actually, because you are doing nothing, basically just adding all the digits 2 times.
So Roger, for this approach, if we take 1999,
okay,
if that is the number given, then how will it actually work?
1999. Okay, so what will have then? What will be the sum of the number, right? It will be 28, right?
Correct.
Like first, without doing anything, if we just look at it here, that would be the first. Second one would be like 0 plus 999. So 27. So I think 199 will have the best answer. You can't make anything better than that. Like 28 would be the best answer.
Okay, so we will compare actually before.
Yeah.
Without doing this and with this, correct?
Yeah, both the options we will compare.
Okay. Thanks.
Yeah, no problem. So third example was normal, like, you look at the thing, there is some insight and you recognize some very nice pattern, and then it can give you the right answer. So, all right, so we are done with everything which I wanted to cover before digit DP. Now my problem will change. Let's do other problem. Okay, anybody can answer. I want sum of all the digits between 1 to 9. Between 1 to 9, so it means 1, 2, 3, 4, 5, 6, 7, 8, 9.
N minus 1 by 2.
N into n plus. Is it, or it is n into n plus 1 by 2?
Plus.
Yeah, n plus 1.
Sorry, plus.
Okay.
Plus 1.
Yeah. So basically 9 into 10 by 2, 45, right? Basically 1, 2, 3, 4, up to 9. Okay. Now I'm changing my problem that, okay, give me the sum from 1 to 99, but not like that. I'm not asking you to give me the sum from 1 up to 99 where you can just apply this formula. So 1, 2, 3, up to 9 like this, right? And then you have 10, 11, 12, something like this, 97, 98, 99. Now, this means 18, sum of the digits. This means 17, this means 16, and like that. How would you do that?
So we can basically keep a count of each number, like how many times it is occurring.
Okay.
I guess we have to take a recursion approach here, or putting into the array of this those one is whatever size we have given.
I have a question. That 1 to 99. So you have the sum after that. What is that we are asking here?
Sorry, can you repeat the question?
Yeah. So what I was asking, like, so from 1 to 99, so we add the sums, and then what was the question from that? We need a sum, is it?
Yes, sum of all the digits which are between 1 to 99. So basically 1 to 9 you have no problem because they are single digit number. For 10 you will just add 1. For 11 you will add 2. For you will add 3, something
and then
like that.
From that 1 to 99, what is the sum? Is it?
Exactly. Okay. Yeah.
So I think what I said would probably work. Yeah.
So I was just trying to identify a pattern here. So every sequence of 10, there is a pattern which is continuously repeating, right? From 1 to 9, I have got 1, 2, 3, 4, 5, 6. So from 11 to 19 as well, I have 1 to 9 as at the unit digit and just 1 at the tens digit.
Right.
So I'm having 1 to 9 10 times, and then 1, 2, 3, 4 as 9 times into 9 times, I guess. Yeah. So there is a pattern which we can identify and just prepare a formula to just track that pattern.
Got it.
Actually 10 times maybe, because the first one is, we can assume the first one is having the prefix 0. So 1 is nothing but 0, 1, 0, 2, 0, 3. Then the 0 becomes 1, the prefix becomes 1. That's why we are getting the sequence 10 to 19. Then 2, 20 to 29. Like that it goes up to 90 to 99. So actually the prefix is changing from 0, 1, 2, 3 up to 9, which is 10 times.
So each of the digit is coming 20 times approximately, right?
Got it. So what Rajendra was saying is, and also kind of what Bhumik was saying, very similar, and mm, they will actually lead to the digit TP approach. So that's good. Since you guys know and figured that out, that's great. But when I think as a, like, what would be my brute force approach? If I have to do it 1 to 99, I don't know anything. What I will do, if I have a function like where that function is given a digit function called n, and if I can keep summing that all the digits in that, that function you have, then I can run that function 100 times and I can get the answer. Will that work? Like, for example, if I have given like f56, what it will do, it will first get 6, and then in next time it will get suppose 5 by,
Yeah, got it. Modulo.
kind of thing, modulo. And so for 1 to 99, that solution may work, right? It shouldn't be that bad.
Yeah.
So that would be my brute force approach.
So Roger, one more.
Yeah.
So just thinking, one more approach is like, if you look at 1 to 10, right? So we are adding like n into n plus 1 would work. And if you look at 20 to 29, that's again like 2, 3, 4, 5, 10.
Right.
Right.
Right. You are right.
Yeah.
Yeah. I mean, identifying that pattern, now you also identified that. That is the whole point of digit DP. Like, you have to identify the pattern that, hey, like, am I doing similar thing again and again? Can I do something about it? So, but problem with my approach, so we will go there. We'll go in detail there. So problem with my approach of brute force would be now suppose you are given a number, suppose which is more than 10 to the power 9, let's call it 10 to the power 18. You are not supposed to answer 1 to 99, but 10 to the power 18, that's your range. In that case, most likely my approach will time out, right? Because I have to just loop through these many numbers, and then these numbers could have 18 digits. So in worst case, so I will doing that mod of operation that many times for each digit, it will definitely be timeout. So that is why now, as a couple of folks suggested, that identifying a pattern should help us with not doing similar thing again and again. Can we reuse this computation which we just did here? Something like that, right? And that is the core reason or core idea about digit DP, which we will delve into now. We'll see how we can use it. So suppose your number is not that big. Just for explanation, my number was suppose 1 up to 9999, not more than that, just to illustrate it. So as we were seeing, we have to fill these 4 values, like we'll see.
Roger?
Yeah, go ahead.
Sorry, while you were explaining, I was trying to work it out. So one of the things, I don't know if this will help in our analysis, but one of the things we can see is that, let's say we compute the sum for 13, 1, 3.
Okay.
So 13 sum is going to be 4, right? 1, 3.
Right.
Now, when we go to, let's say 23, I can see that one way to do is to sum 2 plus 3, which is 5. But other way to understand is that 3 is the common digit in both of them. And only the one digit that was number 1 has changed to 2. So if I take the answer of 13, which is 4, and I add 1, then it gives me answer for 23. And so on. Basically, I'm just seeing which digit changed, and that digit adds 1 to the answer instead of summing it all over. Is that the thought process?
The thought process is good on the right line. I think what Rajender suggested, that when you are calculating 23, instead of looking at 1, 3, why not directly look at 0, 3? I think because then you can add 2 to whatever was the value for 0, 3, right?
Yes, yes, correct. So only keep the base digits. Everything is going to be derived from the base digits 0 to 9 or 1 to 9.
Right. So we will look at how that will work. So I'm pretty sure you will understand it soon. So hold on that thought. Okay.
Rajat, one thing.
Yeah.
Yeah. So like as you mentioned, like from here we can observe that we'll crack a pattern and that we can use to store the result of small sub problems. But should we not go by approach of like writing a recursive function and see that this function is dependent on which things and then identify which of the overlapping sub problems we have. So from there we can intuitively conclude a pattern what it is going.
Yeah.
Right? Because
but see, you are right, and you have made the assumption that I am going to find a pattern and I am not going to do recursion. So
correct.
yeah. So yeah, that is what I am going to actually.
Yeah.
Okay.
Yes. Because as you know, once we write recursion, right, we have a function, we know that this function takes 2-3 parameters and these values are overlapping, or we can make a DP on the face of state of the function that it is taking. So it becomes very easy to deduce a pattern from there.
Exactly.
Yes.
So I think a couple of folks already suggested, and let's do it now. Okay, let me just worry about this most significant digit. Suppose by magic of recursion, induction, whatever magic you say, this is supposed taken care of. Let's think now that we know the sum for all these values. Then on first value or on first digit, what can I put? I can put anything from 0 to 9, right? Suppose this sum was S, right? Then if I put 0, my overall sum will be 0 plus S. If I put 1, then it will be 1 plus S. For 2, it will be 2 plus S, and so on to 9 plus S. Does that make sense?
Yes.
Suppose randomly I have put 1, 5, 8. So the sum was 14 for S. If I put 0, my number is actually just 3-digit number because the most significant digit is 0, and the sum will be 14. If I put 1, 1, 5, 8, then this will become 15. 2, 1, 5, 8, that will become 16, and so on, right? So what is the thing you are saying? Hey, for the current digit, I only have to run a loop from maybe 0 to 9. And this is it my smaller problem? If it was like, if I call this digit size was n, can I call this digit size was n minus 1? So if I solve that problem and just solve for the current digit, then I should have an answer. That's the idea of recursion here. So let me draw a tree also to explain. I need some space. So let me see if I can make more space here. Okay. So what we are saying that from here, let's go. I don't know, 10 times. You choose 0, 1, 2, 3, 4, 5 up to 9. And then from this again, you will have 10 of these branches. Or with all of those, you will have 10 branches. And when you will reach finally to a level, like maybe here, maybe here, when you have only one digit left, basically, suppose you are on you are working with the last digit, then you can start to just propagate up the sum. Like, hey, it was just 1, then just return 1. If this value was just 2, just return 2, and like that. So
So,
that question.
so yeah, so Roger, why did you take the range from 0 to 9 only? Like, was it because the most significant bit was 9 already? Because that will change according to it, right?
Yeah, so my problem is specifically I said 1 to, I don't know where it is, 1 to 9999.
4 nines, okay.
Yeah, yeah.
So had it been 5999, so the range for first would be 0 to 5.
Yes, and I will discuss that next.
Okay.
Okay. Once we are clear about this, we will go there.
Yeah. Okay.
Yeah. So does this make sense, guys? Like this needs a knowledge of recursion, but can you understand the recursive nature of this problem?
Yes.
Yeah.
Okay. I assume yes. That's right. Okay. So far so good. Now I was going to that idea where you don't have 1999. Now you have, say, what was the example? 5623? I don't know, something like that. 125623. Now, what should be, now it's interesting. What can you put on the first position? So I'm
0 to
talking
5.
first digit, yeah. First digit. Okay, so 0 to 5, that's right. 0 to 5, I can put 0 to 5. Okay, that's good. Suppose I put, okay, let me make sub case. And you know why we need that sub case. Suppose if I put 0 to 4 here, so if I put 4 here, can I put here 0 to 9 on
Yeah.
all these questions?
Yeah.
Because yeah, that's a good idea, because if I put 0 to 4, then next digit, if I put 0 to 9, I am still within the range of my overall range. Does that make sense, guys? It's very important.
Yes, yeah.
Please ask now. Like if you have doubt in this section, then nothing will make sense in future. So just make sure that you get this part done.
The number starts from 1 and you are using digits from 0 to 5, or it should be 1 to 5.
Yeah,
Numbers.
so you know, if you sum anything with 0, it's still 0, right? So that's why I'm willing to make that, you know, simplify that. Okay.
With this, we are missing a case, but maybe we'll handle that case later, right? The 5 case, if you only do 0 to 4.
Yeah, that's the next thing.
Okay. Yep.
Now, yeah, that was the easy case. If I choose 0 to 4, I can put anything, 0, 1, 2, 3, anything here, anything here, anything here. It's not a problem. But if I choose 5, for example, if I choose 5 here, then what can I put in next digit, for example?
0 to 6.
Okay.
0 to 6.
Anyone else?
I think we'll again have 2 options.
Why 0 to
0 to 5?
Like, yeah, like 0 to 5 and 6. At every digit, we can break it into 2 cases.
Yeah,
Yeah,
it will be 2 cases, yeah. Until
one less than that.
So next digit will have 0 to 6. Because if I have 5, if I can choose 6, I'm still in the range, because I can always select 0, 0 here. And I will be in the range of 5, 6, 2, 3. That I don't want to cross this range. So I will still be able to choose anything, but only from 0 to 6 in this particular case.
But it won't give you the maximum sum then.
Problem is not maximum sum, right?
Like digits, okay.
We are going to sum all the
Yeah, go.
all the numbers.
I got confused.
Okay.
Somebody suggested that you can choose from 0 to 5, then you
And
can
then 6.
0 to 9. No, like for the first case we did, right? 0 to 4 and 5. So for the next digit, when we come to 5, we are saying that that is the, we don't have two cases there. Sorry, I just got confused.
So for the first digit, we had this case. Okay. Now we have two choices, either 0 to 4 or 5, because they will determine our future. If we have 0 to 4, then for the next set of all the digits, I don't need to worry, because I know anything I choose in future will be smaller than my range, right? Because you choose first digit as 4. Doesn't matter what you choose here. You are totally free to choose whatever you want. But if you chose 5 here, then it matters what you choose here. You first of all, you can't choose 7, 8, 9 for sure, and that is already determined here. But if you choose 6, then that problem still propagates. Hey, if you have chosen 2, then for the next digit you can't choose anything more than 2. Look at it. 5, 6, then you can't choose anything more than 2. Otherwise you will cross the range. However, if at this position, had you chosen anything from 0 to 5, let's say 5, then I can choose anything, right? I can choose 9, 9, then I can make 5, 5, 9, 9. I could have made that. So this is the most important observation for the digit DP, that what you choose in the most significant digit, that will determine your next choices of the digit.
So when we wrote that second branch, 5 to next digit 0 to 6, in that also we will have two branches, right? Either we choose from 0 to 5 or we choose 6.
Can you repeat? I couldn't hear your voice in like last couple of seconds.
So the second branch we drew, 5 to next digit 0 to 6, that line, from there will be two branches, right? One will say, I chose from 0 to 5, and then the next digits can be 0 to 9.
Right.
Second branch will be, I chose 5, in which case the next digits will be 0 to 2.
Right. Okay. That's right. Exactly. Same thing. Like same this kind of branching will propagate as for all the digits, and it it totally depends on what choices we made with the previous digit. It will determine current digit's future, right? So is that, at least idea is, don't think about how we will do it. That will just that's not important. But does everybody understand what we are doing and why we worry about the why these two cases are different? Why do we need to worry about this case especially?
Yep. Sense.
Yeah, if it is clear, then now we will go to the next idea. Okay, so what we learned along the way, that I have this concept of restriction, right? Sometimes for any digit, I am restricted to choose numbers. Sometimes I have no restrictions, right? So I have a Boolean variable which I need to somehow propagate, that, hey, am I restricted or not? If I'm not restricted, don't worry. I know I will just choose everything from 0 to 9. But if I have the restriction, then I have to do something else. So you have to think about the restriction. This is a one important variable which will play a role. Okay.
So Raju,
Yeah.
sorry, one last question. So when we are at the last digit, we cannot have the 0 to 9 case. It will
Right.
only be whatever it is.
Right.
Right?
Yeah,
Like
last.
if I'm at 3, I cannot, I mean, once I come from 2 to 3, at that point, 3 is the only choice available.
Right.
Yeah, that will be the base case, I guess.
That depends on the previous digit what you have taken last will be determined, right?
Correct.
Yep.
Correct.
So your previous digit determines your future's range, basically. Whether that guy has put restriction on you or not. Let's call it like that. The previous guy puts a restriction on the current guy. Then when you are at 3, and if we had followed 5, 6, 2 already, then we know, yeah, my range is 0 to 3. I can't go anything more than that. So, okay, let's look at, so we know this is important. This is definitely important. So what we are doing, we are going to all the digits one by one, right? In this mode, like start with this. We try to follow, like, make a choice and put the restriction on the next guy, right? This guy will do the same thing. It will add its own digit, like say call it D1, and it will put a restriction on this guy and continue to follow.
Do we need to put the restriction on the next subproblem also? Because this is the 4th digit, and if we take care of the first digit, that restriction.
So if you look at this, if somebody made a selection of choosing 0 to 4,
yeah,
then there will be no restriction in future. That is for sure, right?
For the first digit we need 0 to 4, and the another one will be 5. Right?
So
for the first digit.
So yeah, first digit, you have 2 cases, right?
Yeah.
If you chose 0 to 4, then in future, for no one, like, there will be no restriction in future.
No restriction, yeah. That is what I wanted to understand, yeah.
Yeah.
So subproblem will not have the restriction.
Yeah.
Yeah, okay, thanks.
So you will have to propagate that. And when you are done with this, so as we do in the base case, when you are here, like you have handle 5, 6, 2, 3, everything up to digit 4. And when you reach here, you have nothing to do, right? So what I am like, kind of, I can pass something like sum while I am building this. And when I reach here, I will just add that sum to my overall result, because I formed a new number and I just want to add that to sum. For example, if I selected here 1, let's call it 3, and then here I selected 2, and then I selected 1, and then I selected 5, and then I selected nothing, because we have already formed, like, 4-digit number. Then I will continue to add this sum 3 plus 2, 5 plus 1, 6 plus 5, 11. And I will just, on the base case, add that sum to my overall sum. Is that clear? I'm showing the same thing, only in this tree, by the way. We are building one number.
Yeah, that's clear.
This was first digit. So sorry, you can't see my maybe marker. 3, 2, 1, and 5. So all these numbers we have, that was your different digits which you have selected. And when you cross the range, then you will just, that is your base case, you will finish your recursion and you will add the sum. So what you are worried about is definitely whether there is a restriction, what is the sum, what is the position, what you are currently working on. Like these are my positions, D0, D1, D2, D3. And that's it, actually. Based on that, we can write a recursion formula. And we will see, like, when we will do the first problem, First problem is exactly the same problem. So that will clarify even more. So if this is clear, I have another small related problem related to this problem. So
Is there repeated work here with this algorithm? Is there duplicated work or no?
Duplicate will work, why not?
No, I'm asking, is there duplicate work that could be cached or maybe I'm just, yeah.
Oh, yeah. I mean, that I think we identified a little bit when who was talking about it, that once you have already calculated 1 to 9, should we just remember this when I'm going through one? Like, should I again go through that branch? So in my approach, I will memorize it. There is possibility to do bottom DP, but we will just do top down. We'll just memorize the previous sums.
Okay, yeah. Thank you.
Okay, no problem. Thanks for the question. So now my question was, does everybody understand this bit? Because if you understand this, then everything hopefully will make more sense and you will understand the core basics. If you don't, then it wouldn't be useful. So I'm okay to spend more time if you want.
Roger, one question.
Yeah.
So wouldn't time complexity will again become n raised to n here?
We will see when we memorize what will happen. That we will talk shortly. Okay.
Okay.
Yeah. It will not be like that, because you have couple of things which are changing in this function. For example, okay, let me give you that idea. Restriction.
Okay, probably we will have only two parameters. One is the digit and another one is the true or false, something like that.
Yeah, we'll have only couple of parameters which will change, and we'll memorize it.
Okay.
Roger, just validating my understanding here. So this sum is we are carrying over, position as we are moving, that's the index. The restriction, so based on the whether restriction is true or false, and looking at the number that I have at the position, I can figure out whether I can choose from 0 to n or 0 to the number at position -1.
Exactly. Yeah.
Okay.
Yeah, that would simplify your coding part a lot if you pass on your restriction. So yeah, what else? Okay. So if there is no question, I will ask a related question, which we just...
Can you show the repeated work in the recursion that we have seen?
Yeah, we just talked about we will memorize things. So we'll do that. That if some state has already been calculated, then don't again calculate, just return it. Right? That was your question.
Like I was asking, can you show what, how is that repetition happening?
Sure. So we briefly talked about it.
Like in the recursion, like in the recursive tree, you can somehow tell.
Right. So, okay, let's think about something I'm working on. Let's just take two digit numbers, right?
Yeah.
So this guy will say, hey, get me all the sum for everything, right? I don't know, like 0 up to 9. And these guys are returning this value to 0.
Yeah, like you can take a 2-digit number, like say 53.
Yeah, let me see. So this was 0, this was 1, this was 2, this is like this up to 9, right? So when I'm working on 1 and everything similar.
Yeah, okay.
So, everything what we have done here is exactly that tree would be called, right? Because this guy will return 45, 0 plus 0 up to 9, sum is 45. If I run this thing, it will get me the same thing. So what I will say, hey, whenever you do that, Just remember it. When I am here, I will ask you, just return me the calculated number.
Yeah.
Like we do it Fibonacci or any, you know.
Yeah. Okay. Thanks.
Yeah, no problem.
So Roger, we are using here memorization part of the dynamic programming, right?
Yeah, we will use memoization part of the dynamic programming. We are not doing bottom-up DP.
Okay.
Okay.
Roger, sorry. Oh, go ahead.
Go ahead.
Yeah. So like digit DP is usually done in top down, or we are only doing it today for top down.
It is possible to do in both. My examples and what I have done is based on top down. That's the general problem, right? With any dynamic programming thing, you can choose whatever is easier for you, or it makes more sense. If you already know your recurrence relations, sometimes doing bottom up is easy. And also I have heard like people with experience, when you write a lot of dynamic programming code, it will be second nature to you. So it's a choice. Yeah.
Roger,
yeah.
When you were explaining that tree where you are memoizing, what is the parameters in the state that we are saying this will be a match? So the state that will store for memoization, is it just the position, or it should be something else also, right?
Yeah, so what I am doing, I will show in the code when we will go into that detail, that anything which is changing, right? That is your state basically, right?
Yeah.
Yes, that is like general for any recursive programming. Like anything which changes, basically you have a change in state, just memorize it. And then you will know there would be a limit on those positions. Like I know this position, like for 4-digit number, I can have 0 up to 4 or something, right? Or 0 to 5 if I want to have some buffer. This sum also, I know I will have, in best case, like all the digits are 9. So 9 plus 9 plus 9 plus 9. I know nothing will be bigger than 36. So maybe if I will have buffer 40. For position, maybe I have buffer 5. Restriction is a Boolean value, right? Which will be true or false. So I can say my time complexity would be 5 into 40 into 2. Something like this. This will be my bound, even space wise, I guess. Because I will have these many states. Does that make sense? Because these are the 3 values which can change.
What is this 40?
40 is the maximum sum which is possible for a 4-digit. Actually, it is 36, right?
Yeah.
And with this restriction, since the number was just 5623, it will be even less. It will not even be that. It will be 4 and
that is
all
the maximum basically. Okay, got it.
Yeah. So something like that. So that will be my basis of when I will do the DP and memoization. We'll look at it.
So it's basically saying if I came with the same restriction at the same position with the same sum,
exactly,
then return the cached value.
Exactly.
Okay. Thanks.
Got it. So are you guys ready for my question related to this understanding? Now I was doing 1 to 5623. Sorry, 5623. Now my question is, I want a sum from, for example, 2259 to 5623. Give me sum of digit for this.
We can calculate for both the things and subtract the first one from the second.
Okay. So suppose for 5623, suppose 5623, you are saying from 1 to 563, let's call the sum is S2, let's call, because that's the second guy. And you are saying from 1 to 2 to 59?
Yeah.
Or 58, think about it.
It should be. Is it inclusive the 2259?
2259. Okay.
I just wanted to know whether it is inclusive. The both the range.
Yeah. They are inclusive.
Then it will be 2258, I guess.
Right. And that's a very good idea. I will explain now to people who are thinking. So there's simple thing. You want to know the sum from this area to this area.
So in this, we can basically have the same idea. The only thing is that when we pass the restriction, now instead of 0 to 9, I'm kind of restricted in the, I mean, so we had two branches, right? So for the, like, in the first example, we were saying, if I choose the digit that is there at position, the next digits can only be from 0 to the next digit minus 1. But if we chose, let's say for the, if we go a little bit to the top where you had that tree.
Go to top, okay.
Yeah. Where was that? Yeah, little down. Yeah, so in this, when we said that for 5, I have freedom, for 5, I'm constraining 0 to 6. So I think that should still go. But now, when I go from 0 to 4, my next digit constraint will not be 0 to 9. I maybe have to look at the first digit, when the first numbers, similar index, and maybe from 0 to min of the numbers, something like that. Like I won't have freedom to choose from 0 to 9 because then I have to look at the previous, the first number also now.
Okay.
So basically considering both the restrictions.
So actually, I think if I understand, let's first understand the easy approach and what I was planning to cover. And you can just get that based on what we have derived so far. Here we want to get the sum from in this range, right? In this S1 to S2 range. And we have the formula to find from 1 to the end. So what we are saying that why not we get sum from 1 to S2? S2 means like 1 to 5, 6, 2, 3 in this example. Also get sum from 1 to 2 to 5, 8, not 2 to 5, 9. Because if we do 2 to 5, 9, then we will miss this guy. We want to include this guy too. So get that sum and just remove this. And with the same approach and same function, you will be able to get the overall sum. However, if you want to generate numbers from here, like starting with 2259 up to 5623, then you have to think about more states, how to start. Like your first number should be always starting with 22. So I haven't done that, and with more states, it should be doable.
Will
Does that make sense?
actually work? Because we may have, I mean, if we see like from 0 to 2259, maybe it's like 1 something with lot of 9s in it. And then the second guy's 9s will be nullified by that 9.
No, you can, I mean, depends on how you implement. Maybe you will just do that, hey, like generate all the numbers and keep sum of two sums, S1 and S2. And only if my number is 2259 in that range, add it to sum of S1 and add to the another range if this value is in. So you have like, you know, different restrictions for different numbers. I mean, it's an implementation detail. I don't want to go into that. But you can write one function to do it if you want. should be doable.
So when we calculate the number, the sum for the smaller number, right, 2259, we already have some memo in there, and we keep that memo in there, and we use it to calculate 5623. Then I think it would reduce the time complexity.
Yeah, if you can reuse it, and you are actually iterating through all the numbers from 1 to 5623, and while doing that you are handling that, yes, then you will just save some time. I will not like to go into that. It's a basic thing. So is this clear to everyone? So if it is clear, then actually now we will go to the code.
Yes.
Okay, great. So we have finished the theory of digit DP. This is only this idea. We will go through more problems depending on the time we have, and then you will see how you can solve almost all the problems using that. So I will take 1 minute break. Why don't you guys read this problem? I think I have already explained this problem. Try to read the example, and then we will solve this.
Roger, this is the same problem that we just covered, right?
Yes, yes.
Okay.
Okay, I am back. So one last thing before, so the generalization is normally you will be given two range. Let's call it L1 to L2 of the numbers. And between those two ranges, you will see that whether the numbers between those ranges satisfy certain property. And based on that, you will have all the problems. Like sometimes it can say, hey, how many numbers within that range is divisible by 7, or how many numbers between that range is prime. Could be, okay, if you do modulo 100, not 100, like something 13, then it returns 5, something like that. So you have this framework where how you will go through that, and most of the time this will change. And depending on how this changes, your complexity of the problem will increase. But the theory you needed is sufficient in my opinion. Okay.
Do you mean like here FX is calculating the sum of all the numbers and it may change?
Exactly. That's why we have a lot of questions. And now we will just see how the same idea will apply to all those. We'll not have time to do many questions, but in next session we will be able to, since now the theory is out of the way, we can do that. So this problem, it's clear to everyone, right? It's the exact same problem which we were discussing.
This is a little bit different, right? In that we were discussing the max sum, and this is just plain summing up the digits.
We were just discussing currently summing of the digit, by the way. This one was, that was another problem. Currently we were just here, we were discussing If you remember, we were just discussing 1 to 9, and then we will use that sum, right? Digit sum.
Okay.
Doesn't matter. Doesn't matter. Like, we can just look at it now. So idea is for all the numbers between 28 to 31, and what are those numbers? 28, 29, 30, 31. What would be the sum? So 10 plus 11 plus 3 plus 4, which is 28. And this is how they have, like, they will have test cases. 0 to 10 will have some 46. 28 to 31 will have some 28. And this is the case. Also look at the ranges. The numbers could be up to 10 to the power 15. So what does that also mean? That if you try to run the brute force approach, which I discussed, that will time out. All right. So with that, we were discussing the same problem. We'll go to the code. Let me know if I should increase the font or something. Is it better?
Yeah, it's good.
Or do you need more? Tell me. I have to just press a button.
Increase it more.
It's
Yeah.
fine.
Okay.
So Roger, sorry, 1 second, just to clarify. So what this problem is summing up the digits from range A to B. What is the problem here?
Look at it. Digit sum between 28 to 31. So for 28, you are saying 2 plus 8. For 29, you are saying 2 plus 9. For 30, you are saying 3 plus 0. And 3 plus 1 for 31. So yeah, it is a digit sum of all the digits. Cumulative sum of all the digits, let's say.
Okay. Okay. Because earlier, I think at some point we were discussing getting the max on a range.
Yeah, that was a previous problem, like previous to previous.
Okay.
But is it clear now?
Yeah, clear. Thank you.
Great. So we'll go through something which is not useful. So these are number of test cases. Don't worry about it. How I read it. Also, since the numbers were more than 10 to the power 15, I'm converting it into a string. You could have converted it into an array or something. So that is also not useful. We'll go to the core part very soon. Okay. So we had two numbers, the left and right. So what I am saying that, okay, if a equal to 0 means like this case, something like this, 0 to 10, then I don't have to run this kind of logic which we just discussed here, if you remember. I don't have to run that kind of logic, right?
Agree.
Because first number is 0, then why do I need to worry about that? So I handled it in a different way. For the other case, when you have actual two ranges, then we will just calculate those two value and I will subtract most likely, something like that. Look at my code. So, okay, that's the piece. We'll go to the main part and then we can come back. So don't worry. So, okay, let's look at what is the final call. So sum is the main function. If you are doing LeetCode, most likely you will have given all this thing for you. You have to just write this code. So a string is basically your string value. So if the value was 359, then think about it, it's a string 359. And then I am looking at position, sum, and restricted. If you remember, we were talking about three parameters in this particular case: restriction, sum, and position. So those are my parameters. Okay. All right. So now look at your base case. So we are forming number one by one, right? When we are forming number one by one and we have accumulated everything, So this will be your case when you have, let me show you here, you formed a number. So you formed 3 to 5 here. Can you see my cursor, guys?
Yeah.
Yeah.
Okay, great. So suppose it was a 4-digit number and I formed 3, 2, 1, 5, and then I'm going to the next digit and there is no digit. So what I want to do, that whatever sum I have accumulated so far, just add it to my result or return it, right? Just return it. So that would be my base case here. So I have just accumulated some here, and then if I reach that, then I will just return it. Otherwise, this is your core piece. Actually, this should be here on the next line. But here is the memoization part, that 3 values are changing: position, sum, and restricted. And by default, I have populated it with -1 to tell me that I haven't calculated it yet. But if I have calculated, just return me, don't do anything. That's the memoization part, not much. Then here is the core piece. Okay. Okay, so what would be my limit? So if I'm restricted, so like restricted is a Boolean value, but since I am using integer, 1 means actually it is restricted and 0 means it is not restricted. In Java, you don't have like that, but I think in C++, they have the meaning that 0 means false, right? But yeah, just look at it that, okay, this value is, if it is restricted, then the limit would be only up to whatever that value is on the current position. So for the first position, for example, if the number is 5623, right? What I will say, hey, when you are starting things, I'm already giving you a restriction to begin with, because I know the further next guys will propagate it. But when I am calling this function myself, I am already putting a restriction that aware about your first value. So that is the restricted part. So now this guy cannot choose anything from 0 to 9, but it has to choose whatever was the value at that position. So if the number was 5623, then my limit would be 5. I cannot choose anything more than 5. Does that make sense?
You can choose lesser values, right?
Pardon?
You can choose lesser values, right? 1, 2, 3, 4.
Yeah, but limit is my upper limit. Let's call it upper limit.
Yeah, 5 is the upper limit, right? Okay, got it.
Yeah, that's my limit, like upper limit. If not, suppose the like first I chose 4. From the next subsequent values, I will not have any restriction. So in that case, I want to choose everything up to 9, right? Because my limit could be anything from 0 to 9. Is that clear? Choosing of the restriction. We'll see how we will use it, and after that, it's nothing, like you are going through the limit and you are summing up your current value. We'll go through this. This is just the selection for the next function. Don't look at it. For all these limits, what we are saying, hey, for the current one, let me tell you the sum is whatever is the current index. If it was 0, then 0. If it was 1, 2, 3, 4, 5, whatever, that's the sum. And go to the next position, and here is the new restriction for you. Because if I choose some value, like if my number was 5623 and I am choosing 4, then I will make sure that my next new restricted value will be 0, so that the next position guy, he can go and choose up to 9. But if I'm choosing 5, then I would make sure that no, don't remove the restriction, just propagate it.
Okay, got it. You have coded it very smartly, man. Actually, I solved any problem of similar kind, but I messed up in coding it.
Yeah, no problem. And you will see
One more question. Can you explain the state of the DP memoization? Position, sum, and restricted. I understand position and restricted. The sum, how we are, what does that mean?
So what I'm saying, like in general, and sometimes you will see that you can get by with doing less number of states. What I'm seeing in this function, what is changing? Position is changing for sure, right? Look at it. Position is going to change. Sum is changing, right? If I choose 5, then the sum will be 5. Whatever was the previous sum plus 5. And then restriction will also change, right? So based on that, I am saying just have all the possible changing values as my state. I don't want to think about what is happening. If things are changing, it's a new state from function perspective, right?
Okay.
So
Yeah.
one doubt, like sum is actually the sum that I have gotten from my if I think in terms of tree, so from the upper branch. So why would my smaller problem state depend on the sum that I am getting from the previous digit?
Your voice was breaking, but if let me try. You are saying why this state depends on the next state? Are you asking like that question?
No, so I'm asking like sum is basically what I've got, what I've gotten from the previous choices of digits, right?
Mm-hmm.
So how does my further sub problem depends on that previous sum? How does the state of my sub problem depends on?
Yeah. So in this code, what I am doing, I'm just passing my sum, like as I am building it. So suppose if I selected 3, that I am passing 3 here, and then I am propagating up that sum. So
Yeah, but it's okay that you used it in the parameter, but is it necessary to use it in the DP state also?
okay, so what you are saying that sum, it is possible to do without having the sum as a parameter? Is that your question?
No, can I do it without using it in my DP state? So you're using a 3D DP, right? Look, maybe restricted and actually, but you're having 3 indices in your DP state.
Yeah, Roger, I also think that we can get rid of some value.
Yeah, so on that, I would say that why don't you guys go try it? I haven't, and my core idea was I looked at the restrictions, and whenever I see things are changing, and if I can get it in that limit, I just went ahead.
Okay. Cool. I'll try it out, and if I could do it, I'll share my code.
Do it. But yeah, don't is the kind of I will show you this pattern happening a lot. Then probably you will see why I'm doing this.
Okay. Got it.
I will repeat it a lot. So I did this will be repeated.
I have a question on the new limit, new restricted one.
Yeah.
So so once we looked at whether we are restricted or not, and if we are, we established a new limit. So that is fine. That's 0 to 9 or 0 to whatever is the number that we are at. Now, after that point, we are basically just ignoring how we came, and the new limit, new restricted is only based on the current limit that we established in line 72. So that means that when we were earlier drawing the tree, maybe we should have also looked at what happens when I don't know if we covered that branch, from 0 to 9, if you choose, then how does the restriction propagate? Did we? I'm a bit unclear on how restriction is propagating from that point onwards.
So from 0 to 9, okay, suppose.
What cases? Let's say we came, so if we go back to the drawing board, we were
Yeah.
saying that maybe it's there. It's just haven't thought through. Yeah, this guy. So
Yeah.
now in that the tree that we have down, 0
Mhm.
to 5 and the 2. So now first one 0 to 4 it came with restriction, 5 came without a restriction.
It's the
Or
other way. Other way.
other way, sorry. So now from 0 to 9, if that branch is taken from, then how will the next digit be impacted? And then if I select 5, so in that case, from 0 to 6, how is the restriction flowing? Maybe that's the part I'm not obvious.
So every time we have just two cases, right? Either we have the restriction or not, right? We have just Boolean value. Also, if we don't have restriction, we know what we have to choose, like 0 to 9, right? And if we have the restriction, then suppose I tell this guy, hey, when I'm choosing 6, you have restriction. Then this guy knows, okay, what is my upper limit? My upper limit is 6 because that is what my value is. If the restriction is continue to move forward from 5, 6 to 2, then this guy knows that my limit is 2. Don't think about 9. I can only put 0, 1, 2. And similarly with the last guy, if it is under the restriction, it can put 0, 1, 2, 3. And after that, of course, you go to the base case and then restriction loses meaning. So that we already have handled in the first line, right? That, okay, whatever is the restriction, we are just returning it.
Yeah, so, and maybe I need to look at it closely, but
So
the part where we are
basically, like,
using the part where we are using the restriction that came from the level above, that is fine. But I was thinking, how are we saying that the next guy has to be restricted?
Here we are saying, right?
That I less than limit, that 75 to 77.
Yeah.
That is, I was trying to think how we are determining that.
Yeah, so let me try to continue again. So suppose I am under restriction. So the number was 5623, okay? And in the beginning, I have a restriction already. Suppose I did choose value 5, right? So if I choose the maximum limit which I had, then my new restricted value was still 1, which means I am restricted. For that guy, I didn't open the restriction because this is not less than limit. It actually is equal to limit. So I'm not breaking that restriction chain basically. So for 0, 1, 2, 3, 4, I will say, hey, you guys have no restriction. Go ahead, continue building the numbers, passing the sum. But if you were the 5 guy who had the maximum value, for that I would like to continue with the restriction. So this is kind of simplified in this code.
Okay, I think I got it. Okay.
Great.
Could you explain, because right now you propagate the restriction from the parent down, right? So what if why we need to propagate it down? Or what if we say if I equal limit, which is restricted, equal, so would that still work?
So you are saying that, okay, I'm returning this sum and then I'm trying to
No, I'm saying if I equal limit and then make it restricted. So not to propagate the restrict from parent down to the children. Would that still work?
See, as long as you can pass the restriction, you guys understand the concept, right? That you have to pass the restriction. Don't look into my implementation if it confuses more. It looks easier for me, but the idea is if you choose value which is equal to limit, continue passing the restricted value somehow. If you are actually not choosing the max limit, then you are over the restriction. And that is like how you want to code for that. I mean, so any like question on the implementation side? Okay, one more thing. So I was doing this reset DP array, which is nothing but filling the DP array 2 minus 1. Here was my limit when I was thinking about it. 7 was position, because you remember the number could be up to 10 to the power 15. So if you look at the limit, the number was 10 to the power 15. So I just added 2 more. The sum of the digits for any digit could be maximum 9 into 15. So I just added more, a little bit more here. And this was the Boolean value for basically.
Sorry, what was 9 into 15?
So you can have a number from 10 to the power 15, right? Up to 10 to the power 15. Suppose all the numbers were having just 99999 up to 15 times or maybe 14 times. So this is where I am just adding some extra padding that I don't want to cross that sum, right?
Okay.
And then 2 is the state of your like restricted value, either 0 or 1. Does that make sense? I mean, that is one way. Other way could be, forget about thinking about this. Just define a map. You can create a map, and based on these 3 values, you can create a key for the map with some comma separated or something, and then just you can memorize on that. So then you don't even have to think about what is the values for those possible ranges. It depends on how you want to write that code. In that case, you will just look at your map.getKey, and if it is calculated, just return or go and calculate one. So anybody has any question, or what should we do? Okay, what is going on chat? If somebody is explaining, thanks a lot. Thanks a lot. If it is not clear, then look at this recording, or I will put the code later. Maybe you can go ahead with that. But it's 11 o'clock. I wanted to do more questions. So unfortunately, we don't have much time. So we do one more today and then wrap up? Because since we did this problem, I will choose one problem which is actually very easy. And then it will give you the idea of the power of what we just learned.
Roger, we will be having more sessions on this, right?
We'll have at least one more session, most likely.
Okay.
So, okay, last problem for the today. It should take 10 minutes. So I will go through this problem. See, find the number of integers between 1 and n that contains exactly k non-zero digits when written in base 10. Okay. So you see the pattern. You have a range and you have some property, right? And for example, between 1 to 100, you want one digit, right? Is that the problem?
We have to count
non-zero digit. Sorry. Go ahead.
We have to count basically numbers which has exactly k non-zero digits.
Exactly, yeah. So just one digit, just one non-zero digit from 1 to 100 would be 1, 2, 3, 4, 5, 6, up to 9, no problem. And for 2 digit, you will have all these 2, 3, 0, because you want to have non-zero digits. So idea will be same, just your property of selection will change, right?
Yeah. Got it.
So now see the power of the code, which we just discussed. And now if you look at it, you will say that I'm writing the same thing again and again. You have this thing, string, which is the number, position, I'm counting. I will explain why count. Actually, I wanted to give more time to this, but maybe we'll talk later. I'm just changing the parameters, like, whether it is restricted or not. And that K value, if you remember, that we only have K non-zero digits, right? So for that, I am counting it. When the number is formed and I still have K value, then I will say, hey, I found one number while generating these numbers which satisfy my property. So that would be your basically, if you think about the recursion tree, that was one possible solution. So here you have just generated 16 and it matched the criteria, so it will return you 1. It will tell you, hey, I have found one solution which you may be interested in. So that's why we are returning one value. Same thing, the 3 values were changing there. So I just, as usual, I applied this memoization. I figured out the limit as I do that, hey, if restricted equal to 1, then this will be my value. Otherwise, 9 is good if no restriction. Same thing, I'm going through that loop. It's nothing, forget about this. This is the exact same thing which we just talked about for what I will pass in future. And then we'll go through, if I equal to 0 means the first value is 0 basically. What is the question? I need to talk now. Okay, thanks guys. Yeah. So same thing, if I equal to 0 means like you haven't selected anything yet, right?
Yeah.
So you are just saying count, same count, and but just move ahead with the position. And else, as long as your count is less than K, you just update this thing. You have found the new restricted here using the same pattern, and you continue doing that. You just go through the regular memoization thing. And don't worry, I will explain this maybe in next session more, but I just wanted to give you gut feel of all the problems which you will see. It will look like, hey, this just works. It's a different problem, by the way. I'm not showing you the problem. I'm just telling you this logic will change most of the time. And that logic will be the logic of the problem. And based on that problem, you may have to pass some additional parameters. But with this, I think you guys are okay that you understand the basics of digit DP. You have solved a couple of problems. And if you have time, I would suggest you are in a very good position to solve at least this problem on LeetCode. Think about it. Given an integer n, total number of digit 1 appearing in all non-negative number less than or equal to 1. We were just looking at the similar problem. And it is said that it is hard, but if you have to test whether you understand it or not, I would say go ahead, look at this session's video if you need to, or if you already understand, go ahead and just code this out, and hopefully you will feel more confident. I think that's it for today's session, because we are running out of time, and next session will be
I wanted to ask a question.
Yeah.
So the previous question we were talking about, so I was thinking, can we go iteratively, the number that was 5623, right?
Mm-hmm.
So what I was thinking is, so let's say, we'll go one by one, like from 5, then 6, then 2 and 3. And then what we're doing is, so for each level, so, the tree that we were making, so that goes from 0 to 5, like at level 1, right?
I know.
So what we'll do is, so
Yeah.
the number that we are getting 5, so so let's so it's 5, so 5 into 5 plus 1 by 2, so whatever number is there. So and and for 0 to 4, we can just, what we can do is, because, it's repetitive, like 0 to 9. I mean, like 0 to 4 number is going from 0 to 9. I mean, the next levels, right?
Yeah. I think
So what we can...
if you are interested in the iterative way, I am not sure, like that was the sole question, but then it is talking about the exact same concept I just talked to you about, and it is finding a recurrence relation, like like something like this. Its idea is exact same idea. There are some examples also, but go through it. It depends on which seems like more easier for you. Unfortunately, I have coded all my solutions already in that format, so I don't want to change it. See, like all my idea is based on the same restricted thing and all, so I don't want to give something. Yeah, so people can watch and then they can again apply the.
Roger, one question here. Like the last question which you were mentioning, right, where we need to count the numbers. So there, for I equal to 0, means what is that? Like, I didn't get that part.
Okay, so actually we will discuss that more in next section. Would it be okay if we do that? Because I will try
Just
to
one part I didn't understood for I equal to 0 part. Rest I understood actually.
Yeah.
In
Don't
which
worry.
you are calling the same count.
Right. We'll go through all these problems in next section. Like except the one which we just did. We'll go through all the problems and hopefully that will make more sense. I will draw more, but the thing is we are running out of time. I just wanted to give you a sneak peek of, see the pattern kind of idea you can apply in many situations. That's why I showed that.
Yeah, sure.
Can you please share the text of the questions which you are discussing as well as going to discuss next session?
Yeah, actually it was somewhere in, see, this is our Slack channel. If you look
It
at
was lead code practice.
Yeah, somewhere.
In the lead code practice, you have already.
Here is all the problems which we are going to.
I mean, I did not look that channel, but I did browse around. Okay, thank you. I will take that. Thanks.
Yeah.
Can I ask a quick question about the code, the implementation?
You have a question about implementation? Somebody else?
Yeah, can you go back to the implementation real quick?
Which implementation should I go? Can we stop the recording and then, because there will be, maybe we can talk more.
Yeah, the private long sum function, like